Hey guys, welcome to lesson 4.1, where we discuss the language of research studies. So two types of research studies. There's observational studies, and here researchers only observe, measure, or question participants. No one is actually changing anything, so you can look through data. Example, question people about their exercise and eating habits, then compare exercisers to low-fat eaters. And then there's randomized experiments. And the key to this one is that researchers manipulate something. Participants are randomly assigned to one condition or another, and the effect is measured. Example, randomly assign people to an exercise program or a specific low-fat diet and measure and compare the weight loss. So experiments are stronger. Experiments allow us to ascribe causality. They allow us to say that, for example, some sort of exercise regimen causes better weight loss than another one. So why do observational studies? Random assignment makes the groups approximately alike in every way except the treatment, so confounding is controlled and the difference in outcomes can be attributed to the treatment. That's a reason to do an experiment. But sometimes it's unethical to do an experiment. So for example, you can randomly assign a diet for a semester, but you cannot randomly assign someone to smoke for 20 years. So measuring smoking habits on, for example, the incidence of cancer is something that you cannot set up an experiment for. Also, sometimes it's impractical. So some explanatory variables, age, income, or where people live, simply cannot be assigned. So researchers weigh the options. When both strategies are possible, they choose between the experiment's causal strength, which means one thing causes another, and observational studies, realism, and reach. Confounding variables. A confounding variable is one that both affects the response variable and is related to the explanatory variable. Remember, explanatory variables are things that have an effect on the response variable. Its effect on the response variable cannot be separated from the explanatory variable. We're going to look at an example in a second. So the most important thing is confounding variables create an appearance of a relationship where none exist, or mask a real one. So, for example, do big feet make better readers? Here's the finding. In a study of school children, shoe size and reading ability are strongly related. Basically, kids with bigger feet read better. So shoe size is the explanatory variable, is strongly associated with the reading ability, the response variable. So there seems to be an apparent relationship. But there's a third variable, namely age, which is the confounding variable. So kids that are older tend to have a bigger shoe size. And also kids that are older tend to read better. So there seems to be a causal relationship between shoe size and reading ability, but they're both related to age, and age is actually the thing that is very strongly related to reading ability. In general, we expect older kids to be able to read better. Age passes both conditions. It affects the response. Older kids read better and is related to the explanatory variable. Older kids tend to have bigger feet. Nobody thinks big feet cause a reading skill. Age drives both. So quick check. Let's look at explanatory and response variables. Comparing GPAs in students in sororities versus not sororities. All right, so here, the explanatory variable is whether someone is in a sorority or not, and the GPA is the response variable. Compare the effectiveness of two allergy medications. The type of allergy medication is the explanatory variable, and its effectiveness is the response variable. Do servers get better tips if they introduce themselves by name? So whether they introduce themselves by name is the explanatory variable, and the type of tips they get is the response variable. Is TV time for 6-year-olds associated with bullying at school? So TV time, does it have some sort of association with bullying at school? That's the explanatory and response variable. Quick check, observation study or a randomized experiment. Volunteers are randomly assigned, that's the magic words, to take a new sleep aid or a placebo. Sleep hours are recorded. This would be an experiment. Researchers compare lung health of people who choose to smoke and people who never smoked. That's the explanatory variable. Lung health is the response variable. This would be an observational study. Students are randomly assigned. Again, this is a variable that's being manipulated to study with music or in silence before taking a quiz. Quiz results would be the response variable. The type of studying would be the explanatory variable, and this would be an experiment because the treatments are randomly assigned. A survey compares stress levels of commuters who drive versus those who take the train. So stress levels is the response variable. The type of commuting, so driving versus taking the train, explanatory variable, and this is an observational study. So key term, observational study. Researchers only observe and measure participants. No treatments or conditions are assigned. Randomized experiment. Participants are randomly assigned to participate. A confounding variable is one that affects both the response and is related to the explanatory one. And it sets up a relationship where it seems like there is a relationship between the two, but it's actually the confounding variable that's related to both. An explanatory variable is a variable that may explain or cause differences in response variable, and response variables, the outcome variable that may be affected by the explanatory variable. So quick summary, observational studies watch and measure, randomize experiments, assign conditions by chance, and measure its effect. Experiments give stronger cause and effect evidence, but ethics and practicality often requires observation. So you can only have a cause and effect relationship from an experiment. Explanatory variables may explain differences in response variables. Either can be categorical or quantitative. And a confounding variable, must both affect the response variable and be related to the explanatory variable. Test every candidate against both conditions. And that is lesson 4.1.